Welcome to VTU e-Shikshana program on engineering graphics or engineering drawing. We are in model 1 dealing with straight lines. Now I have a typical problem on straight line. Let me complete it. See, really it is interesting to work such problems so that you can work any problem on straight lines. We have the problem like this. The top view of line PQ measures 70 mm and inclined at 60 degree to xy. The top view of the line is inclined at 60 degree to xy. Whenever they address xy, it is actually the top view or front view. The end Q is 10 mm in front of VP and 30 mm above HP. The difference of distances of ends P and Q above HP is 45 mm. We will discuss what exactly. This is a typical statement. The straight line problems, we get the distance of the other end is the right end is 65 mm above HP, 50 mm in front, like that. But this is a typical statement. We will look into it what exactly this means. Now draw the projections and find the true length and true inclination. Normally true length and true inclinations are given. Here the all data are different. Okay, now let me list what exactly given. In this case we have top view length equal to 70 mm. That is inclined at, that is top view is inclined at 60 degree to xy. That is beta equal to 60 degree. So if you recall the problems which I worked out earlier, the top view is inclined at beta degree, front view is inclined at alpha degree to xy. So next comes the one end. Normally P will be given. See, this is end P, this is end Q. The situation is this. This is the HP and this is VP. The one end is nearer to both HP and VP and other end is away from both HP, VP. Now, the situation is different. This is like this. This is end Q is 30 mm above HP and 10 mm in front of VP. If I take up the simple model of first quadrant and this discuss, it is like this. End Q is 10 mm, 30 mm above HP and 10 mm in front of VP. The top view appears as 60 mm, 60 degree to VP. That means 60 degree to XY line. So this is the situation. Now first we have to fix Q rather than P. P we don't know the position. So first let me fix P and then discuss. Now let me go through this. The difference of distances of ends P and Q. Let me highlight that. This difference of the ends of P and Q above HP is 45 mm. So what do you mean by that? See, above HP the height of Q is 30 mm. Similarly, above HP the height of what? P is X. That means 30 mm plus 45 mm. That's what you mean. 45 mm is the difference of ends of heights from HP. The locus of P, locus of Q and locus of P, this distance is 45 mm. That's what he means. Many times the people take that as front view length, top view length, etc. But it is not the case. This is exactly the vertical height for locus of P and locus of Q. So this is what the difference of distances of ends P and Q. Now let me work out the problem. So this is XY as usual. This is VP, HP. Now end Q we have to fix. Okay. 30 mm above HP and 10 mm in front of VP. This is Q dash. This is Q. Distance is 30 and here this distance is 10. Okay. Now what all given? Top view length is given. Top view is inclined at 60 degree to XY. So draw a line 60 degree and fix the 70 mm length. This is P. Final position of P is available now. Okay. Now, after this, what exactly we can do is dark this portion, because the length is 70 and the corresponding value is 70 mm and 60-degree line. Okay. Now have this angle beta equal to 60 degree. It's very clear. 60 degree. Now, how to fix the locus of P dash in front view area? He says the difference of distance of ends at P and Q above HP is 45. So, this is 30. The 45 mm above that you have to take, draw a line. This length is 45. This height is 45. That's what this says. Total 75. This is 30. This becomes 45. Now, I have to note this as locus of P1 dash and P dash. And I can draw horizontal road in this area also, that is locus of this P and P2. Already we know P. We have to identify P2. Here we don't know anything. P1 dash P. Both we have to find out. Can we draw vertical road or vertical projector of P? Yes. Definitely we can draw vertical projector of P. Keep this vertical projector of P. Directly you get P dash, because this vertical projector is going to house both P and P dash. Because we know the locus, I can fix P dash. Join P dash and Q dash. This gets you direct front view is ready. Top view is already worked out and front view is ready. Now what is this angle? This angle is alpha. You have to measure and say how much. In computer you will get directly the value. Okay, now he says find true length and true inclinations. Whenever final views are available, you can easily rotate and project. That's what. First you have to draw the loci through fixed end. Both are ready now. And we are anticipating here P2. So rotate and project. This is P2. This is P2 dash. Join the P2 dash, P2 and Q. P2 and Q you get true length. So we measure this how much. Either in front view area you can measure or top view area. Both of them. This is given. This is 70 mm given. Now this is P2 and P. Corresponding angle is phi. You have to measure how much and say. So phi equal to how much. True length you measure and say how much. Now I have to find the inclination with respect to HP. How to do it? Repeat the procedure. Rotate this. Assume that it will be somewhere here. It may come across, crossing this also. Since we are working with the sketches, we may get this. So this is, we are anticipating here P1 dash. Now this becomes P1 projected. This is P1 dash. Join the P1 dash and with this is the apparent length, I mean true length. Medium line, this is also medium line. Okay, this angle is theta. So theta you measure and say how much. This is how you can complete the problem on lines which are given with a typical statement like this. So we can also work some more problems on this with various data on computer. So the problem is the top view of the line PQ measures 70 mm and inclined at 60 degree to XY line. The end Q is 10 mm in front of VP and 30 mm above HP. The difference between the distances or difference of distances of the ends P and Q above HP is 45 mm. Draw the projections and find the true length of the line and also find the true inclinations. Okay, so but be very careful in space management here, because you need sufficient distance, because he has given 60 degree, but be very careful and keep the distance. Let me take a little bit here. Okay. Now start working. This is for left end of the line, this is for right end of the line. So take this line command and minimum thickness for fixing end Q. See, this is end Q. Normally we take to the left side if it is P. So Q is given clearly 30 mm above HP. See, the end Q is 10 mm in front of it, 30 mm above HP. Take 30 mm and fix the end Q. And similarly, you mark 10 mm and fix Q dash. So Q dash and Q must be identified properly. So this is Q dash. Let it be block. Yeah. For all practical purposes, you keep black background. This is Q. It's a typical problem. Try to understand clearly. This is 30. This one is 10 mm. Now fix the top view. Since he has given 60 mm, 60 degree to XY line and measure 70 mm. See, here is 70 mm. Okay, directly draw the top view, because he has given the final length and inclination. This Q. I have to fix P final 70 mm and 60 degree. 60 120 you have to keep, minus 120 you have to keep. That's what he says, minus 120. Measure before you proceed with the XY line. Sorry, this. Yeah, it's exactly 60 degree. We verified. Better you draw a thin line through fixed end. Now name this as P. P. Sorry, Q. Q. Sorry, this one is the left end. P. Correct. Q dash P. Now I can fix the locus of P, horizontal road in the HP area, and I can fix the vertical road which moves towards the EP area also. Now before that, let me use this. The difference of distances of ends of P and Q above HP is 45 mm. See, this is 30. Above this you have to take 45. Then it becomes differences of distance of end P above the HP is 45 mm. So measure from this point yeah, 30. Measure from this point 45 mm, so that you will get the locus of, this is the locus of P2 and P. Okay, you can mark here, or totally you can keep 75 and then do it. Not a problem. can write here for clarity. Let me write locus of P2, P1 dash and P dash. P dash. On this line only, these 2 points should lie. That is true length of the line and the final front view line. P dash Q dash is final front view line, and P1 dash and Q is true length. And normally it is P Q1 dash. Now it is reverse because Q is fixed and P is moving end. I can also fix the locus of this. See here, let me take it to another sheet so that you understand better. So what are given, I have identified here. So next I will keep this procedure neatly further what to do. Yes. The top view is given and this one is identified. Now we are left with this. Now let me repeat. See, this is the locus of P2 and P. Thin line. Yes. This is locus of locus of P2 and P. Yes. Okay. Now start working. We can dimension this also because the difference is given clearly. Yes. This is very important. Now how to do it? You can easily draw vertical projector of P so that you will get P dash directly. Once it is marked as per the given data, it is very easy for you to draw the projections and complete the projections. Only thing is you have to chase the requirement and do it accordingly. See here, intersection of the vertical road, horizontal road gets you the destination. So this point is nothing but P. Okay, here is Q dash, P dash, Q dash. So let me name this as P dash. Final projection is ready. This is P dash. Join P dash and Q dash with dark line. 0.5 because this is final. This is Q dash and here is the Q dash intersection. We can trim and then draw end line, dark to end line. Reference is very important. Now it is okay. Now the value of inclinations with the final views are these. This is 60. Let me drag and then move apart. This is 60, this is beta, and how much is alpha? I will check. You can also do that job easily. Yes, it is 0.13. You can dimension it. See, keep this 52 degrees is the alpha value. Now he wants in question, he has asked for true length, find true length and true inclinations. See, this is the thing. This is the projection. Projections, final projections are over. Now we have to get the true length and true inclination. Only after drawing true inclinations, you will get the true lengths and accordingly true inclinations. Now take how to draw the true inclinations. Now whenever you get the final view, you project and rotate. Here we are having the final view, so you rotate and project, that's all. Reverse procedure. So what I do is I will make it parallel. Since I know the paths, true length paths, I can easily get this. Take this arc by center point. This is center, draw. Then project down until you get the locus of P2. You get P2 there. Okay. Yes. P2 there. Project it. Now procedure is this. I will show with arrows. Take this, draw. Again project it on the locus of moving end. This is moving end. Rotate the moving end with respect to fixed end. Project onto the moving end. You get this is P2. P2 is ready. This is P2. Join P2 with Q. P2 with Q. Definitely you get true length. And associated inclination is true inclination. This is true length. Let me measure the angle phi for 7 degrees. How to get the inclination with respect to HP? Do reverse procedure. You take the top view and rotate, make it parallel, and then project onto the moving locus. That's all. Now let me extend this line so that you get the idea of parallel line. Yes. Take arc by center point, rotate the top view length. This is the final top view length. Then move on to the normal position. That means what we did in the starting solving problem, basic problems. We projected and then rotate. Here it is rotate and project. Okay. Now what I did, I have made it reverse procedure. Projected on the locus of moving end. Yes. So I am anticipating here P1 dash. So name this as P1 dash. I hope you are familiar with the naming. If this is P1 dash, this becomes P1. Initially you can write this is P1 because once you rotate this becomes P. PQ1 is top view and corresponding length is front view when it is parallel to HP. So this becomes your P2 dash. Join P1 dash and Q dash. You will get true length of the line. Then check for the angle. That is theta. Theta is 33 degrees. Okay. So true length is P1 dash Q dash. Let me measure how much it is. Both should give same value. Anyway, if there is any difference, then small problem in projection, etc. Yeah, it's exactly 83.2 to both sides. I hope we have completed the problem successfully. So here I repeat, the Q is 10 mm in front of VP and 30 mm above HP. The top view measures 70 mm. Top view measures 70 mm and inclined at 60 degree to XY. And the difference of distances of ends P and Q above HP is 45 mm. So this is what the final solution you are expected to present this way. Okay. So let me identify the parameters which are required as per the question. So let me keep true length equal to here true length equal to 83.22 mm. 83.22 mm and this theta and phi you have to identify. Given, there is one more data given, top view length, top view length is given 60 mm, 70 mm, 70 mm, and beta is given. Now we have to go for this symbol. Beta is given, beta equal to 60 degree, 60 degree, and these are given. Now we are identifying the theta and phi values. Theta q equal to, you have to type q with this symbol. Theta equal to 33 degrees, 33, and phi equal to, sorry, that. So next, let me show this. The symbol is there, I can write. Theta is 33 degrees. Phi f. Yes, you have to type f with respect to symbol reference. It is 47 degrees. 76, 47 degrees. True length is already identified. Top view length is given. This is what we identified. Okay, so better you keep. Yeah, there is no issue. These are given. This we are identifying. One more data is the one end of the line is given. 60 is given. 70 is given, and the other data. This one is given. So you need not worry about that. Just mark this. So this is how you solve a problem on straight line with little bit a different type of data. Okay, so this is how you can solve a problem. So here is the important thing, 45. Majority of the time people take from XY line only, they take 45, or they take the distance of the point Q only 45, etc. So to avoid any confusion, you better go through the problem properly and identify the variables. Next comes the problem on again straight line. I will keep one problem. I think I have done this job. Okay. Yes. Next problem is a line AB has its end A 15 mm above HP and 20 mm in front of VP. The end B is 45 mm in front of VP and 55 mm above HP. The distance between the end projectors is 50 mm. This is a simple problem again, which are given as the data, not the one which I have identified as theta alpha 7 parameters plus 1 parameter distance, but distance between end projector is there. So let us identify the data. To start with, I have end B is 45 mm in front of VP and 55 mm above HP. Okay, both position of end A and position of end B is given. So then you can have the data, but we cannot fix where it is end B, but we can fix the path. That's all. Now this is how you can do it. Check what exactly I am doing carefully. See, 15 mm above HP. This is for end P, end A I am keeping. 15, yes, and 20 mm in front of. Majority of the time you get this value. Okay, but whatever the given value you must take properly. Don't consider this a standard. For any problem given you take this. No. So be careful. Take this dimensions. Please check whether it is correct. Yes. Now 15 mm above HP. Name it immediately. This is A dash. We are in symbol. Change it to times Roman or whatever you like suitably. This is A dash, A dash, this is A. Next comes the, I can fix end A, no problem, but I cannot fix end B, but I can keep the locus, okay, that is horizontal road in both VP area and HP area I can keep, then we can do that job. Little away from the figure, the projection of A. I am not drawing the vertical projector, I am keeping the reference, that's all. 55 mm above HP you keep a line, that's all. Okay, and again 45 mm in front of you keep one more line. This is only to fix the path, that's all, not the vertical projector. What I do is I will draw this line, then remove the vertical line, and then say dimensioning line I can draw afterwards. Okay, it leads to confusion in future. So now what I do is I will dimension this distance between this and this. Okay, 55, and distance between the XY line and this 45. Okay, now I will remove this to avoid any confusion. You could have drawn two lines and dimension it, but better take this and you will get clear idea. Now, what is this actually? This is locus of B2 dash and B1 dash and B dash and B dash, and this is locus of B2. This is locus of B2 and B. Okay, locus of B2 and B. Okay. Now, what else is given? We just check. The distance between the end projector is 50 mm. So it is direct way of working. It's very easy for you. Already I have worked this type of problems. I will just give some hint from this point and then you can proceed. Here I will show you the previous problem where how exactly I worked. Otherwise you can repeat this problem in the coming sessions. See here, you can keep vertical projector, end projector of B. You can, I will introduce one extend to next. See, I am interested to extend this up to this one. Yes, you can just select this, touch this, you will get. This point is B dash. This point is B. So you not draw the extension, I mean one more line and get intersection and do it. This is how you learn the various functions and commands. So this is B dash and this is B. Now join top and front views of ends. Definitely you get final top end of the line itself. See, this is A dash, B dash, and this is AB. In previously worked some problems, we got final views. Then you rotate, project on this line, you get the final, true length line. Again, you rotate this, make it parallel and project, you get the true length line. So I can show you how to do it. See, draw locus of fixed end, locus of fixed end. Rotate this using the arc by center point, make it parallel and rotate. This is what the here we are anticipating B2 dash, B1 dash, this is B1. Okay, let me change the position of B. Let me take this. Control C. Yes. Yeah. Now what I do is I will rotate this and make it parallel, then project, so that you get the true inclination and true length. Yes. Similarly, you rotate this also, primitive area, primitive length. So I am anticipating B2, here I am anticipating B1. Now you can just start with this is B1, you are getting B1 dash here. Here you project the same this point and get B1. Similarly, you project this is actually B2 dash, project and get B2. So I will name this as B1 dash dash. This becomes, this is B1 dash, this is B1. This becomes B2 dash, this is B2. That's what the problems on straight line says. You must be familiar with these notations. You do not necessarily give B1, B2, you can give BP, BQ like that, but better you stick to the convention, it's available and majority of the people use this. Say this is true length of the line in HP area, and this is true length of the line in VP area, and corresponding angle is this. See, this is true inclination with respect to HP. This is true inclination with respect to VP. Very easy to understand. Yes. Then apparent inclinations, definitely you get with respect to the apparent lengths. Okay. Yes. This is 27 degrees. Okay. Since the dimensions are very small, very closely it has come, so it is not that easy to dive. You can keep little bit inside and this one. So theta is 36, phi is 21, alpha equal to 39 and beta equal to 27 degrees. So this is how you can work a problem on straight line and get all the information. Now finally, how to complete the dimensions and all? See, this is how you come in. Because true length is not given, you are going to obtain true length. So both sides you must get same thing. Hope that you'll get. Yes, there is small change because of some this one. You can keep one side and 68.74 is the true length approximately. You must get proper. So let me use this text. True length equal to 68.74, 68.74, okay, mm. Work out some more problems in the coming sessions.